Okay, just picking up from where we left off, we were talking about solving a system of equations by graphing, and how you can see where the two lines cross is the solution of the system. But when you graph, it's hard to tell sometimes actually where the lines do cross exactly. Our first equation, y minus 2x equals 2. If we add 2x to both sides, we'll have y equals 2x plus 2. And that tells me that my y-intercept right here is 2. So there's that point. And then it tells me my slope is 2 right here. So that's 2 over 1. And that would mean you go up 2 and over 1. So that would be that point right there. And then I can draw that line. And then the line y equals negative 3 is the horizontal line that goes through 3 on the y-axis. And so you can see those two lines cross. Definitely the y-coordinate of the point is negative 3, because every point on that horizontal line has a y-coordinate of negative 3. If you look at it, we can't tell exactly what the x-coordinate is. So we can solve this system using substitution. And we're going to take this and plug it in for y in the first equation. So we'll have negative 3 minus 2x equals 2. So if we add 3 to both sides, we'll have negative 2x is equal to 5. So x equals 5 halves. So that point of intersection is 5 halves, negative 3. Okay, lesson 24. First thing I want to talk about is what this means, this mixed number here, 2 3/4. Well, what it means is 2 3/4 more. It means 2 plus 3/4. Okay? The only time that I know of when putting two numbers next to each other in algebra means adding instead of multiplying. And that's why you should never work with mixed numbers when you're solving equations. Mixed numbers are not terrible for answers, and back when you were adding fractions, they were good things to work with. But in algebra, when you're solving an equation or moving things around in an equation, you do not want to use mixed numbers. So don't try to work with mixed numbers in your equations, because this means addition. This means 2 plus 3/4, and that's just different from every other thing you do when you're solving equations. So don't work with mixed numbers. If you have a mixed number, change it to an improper fraction. So remember, you would say 4 times 2 is 8, plus 3 is 11, and that's 11/4. So before you would ever work with something like that in an equation, you would change it to an improper fraction. According to the multiplicative property of equality, we can multiply both sides of an equation by the same non-zero value, and it will not change the solution set of the equation. All right, so there are times when we will want to make an equation look more neat and easy to work with, and that time is usually when the equation is full of fractions. So this equation has it has two mixed numbers. So we want to change those mixed numbers, first of all, into improper fractions. So 2 times 4 is 8, plus 1 is 9. So 9 halves x minus 3/5 equals, and then 4 times 1 plus 1 is 5. So negative 5/4 is on the right side. Now, it's better to solve an equation with whole numbers than with fractions. And since you're going to have to get a common denominator anyway to do this problem, it would be best to just multiply the whole equation through by the common denominator and make all the fractions go away. So remember, when you're working with an equation, you can do this. You can't do this with just an expression. If you had something like 9 halves plus 3/4, you can't just multiply that thing by 4 and say, oh, okay, that's going to cancel out the 2, and that'll be 2, and that'll be 18, plus the 4's cancel, and that'll be 3, so that's 21. No, it's not 21, it's 9 halves plus 3/4, which is 18/4 plus 3/4, sorry, which is 21/4. It's not 21, it's 21/4. So if you don't have an equal sign, if you have something like this, which is called an expression, not an equation, you can't just start multiplying it by anything you want. You can't do that. So that is a no-no. But if you have an equation, you can use the multiplicative property of equality and multiply both sides of the equation by the least common multiple of the denominators, and all the fractions will cancel out. And the solution set to the equation is not going to change. It'll have the same solution set it has right now. And that's the whole point. You change the equation, but you don't change the solution set. So you solve a different equation, but you get the same answer. So that's really the point of the way we solve algebraic equations. We are changing the equation, but in a way that doesn't change what x is. So to find x, we'll start out by multiplying the whole equation by 20. And why am I choosing 20? Because 2 goes into 20, 5 goes into 20, 4 goes into 20, and they all go into 20, and that's the smallest number that they all go into. That's the least common multiple. And so we're going to multiply this whole equation through by 20/1, so both sides of the equation. So when I multiply 9/2 by 20, I'm going to get 10 times 9, because the 2 cancels with the 20, so that's going to be 90x. And then when I multiply 20 by 3/5, the 5 cancels, and I end up with 4 times 3, which is 12. And when I multiply 20 by -5/4, the 4 cancels, and I end up with -25. And now I can add 12 to both sides. 90x equals 13, -13, sorry. So x equals -13/90. And that is the solution of the equation. It's the solution of this equation right here. Even though the equation we ended up solving looks a lot different than that equation, it has the same solution set. So it doesn't matter. We still got the solution to that equation. Okay, here's another one. We're going to do the same exact thing. We're going to multiply both sides of this equation by the least common multiple of 5, 2, and 3. And that is going to be 30. That's the smallest number that all three of those go into. So if I multiply this first fraction by 30, I'm going to go ahead and write it out. 30/1 times the whole thing, 4x plus 2/5. So I multiplied the first thing by 30. Now I'm going to multiply the second thing by 30. Put a subtraction sign. So 30 times 3/2. I'm showing every step this time just to make sure nobody gets lost. And then 30 times 1/3. Okay, so in this first part, 30 cancels with the 5, and I'm left with a 6. So that's 6 times 4x plus 2. Here, the 30 cancels with the 2, and I'm left with 15, and 15 times 3 is 45. And then 30 times 1/3 is just 10. Now I'm going to distribute the 6. So 24x plus 12 minus 45 equals 10. So 24x and then 12 minus 45 is -33. And then I'm going to add 33 to both sides. So 24x is equal to 43. And so x is equal to 43 divided by 24. Now we have an equation where our denominators are 2 and 7. So the least common multiple of 2 and 7 is 14. So I'm going to multiply that by both sides of the equation. I'm going to multiply it by 3x over 2 plus, I'm going to multiply it by 8 minus 4x over 7 equals, I'm going to multiply it by 3. So 14 times 3. So in the first fraction, when I multiply, this is going to cancel. So I'll end up with 21x. And here, the 7 cancels with the 14. So I've got 2 times 8, which is 16, minus 2 times 4x, which is 8x. And then 14 times 3 is 52. So 21x minus 8x is 13x. Subtract 16 on both sides, and you're going to get 36. So x is equal to 36 over 13. And that's all you have to do on those. You just multiply through by the least common denominator, and that will make your fractions go away.